Well, good day, guys. I'm back again. Next episode in the series of how to learn to be a developer using C Sharp. I'm sorry I've been quiet a while. I've been a bit ill, even had a bit of a stint in hospital. But last few days I'm feeling better, and today I think I'm going to make another video. I did make a short one about HTML a few days ago, but it was just a quick, easy one. But alright, so as promised, we're looking at DLLs today, and just remind myself, I must explain to you later what the difference is between a DLL, or a dynamic linked library, and a static linked library. Now, C Sharp itself can produce dynamic linked libraries, and this is what we're going to have a look at today. So I think to start off with, I'll give you a very, very quick idea of what a dynamic linked library is without having to watch the entire video. But of course, if you do watch it, it'll make more sense at the end of the day. But a dynamic linked library is basically a different type of file, not an executable, an exe file that's made when you do C Sharp. It's actually a file that does not end with .exe but .dll. Lots of languages uses dynamic linked libraries and can create dynamic linked libraries. But now in C Sharp specific case, you can share code. Think of it as you have two different programs. The one is the exe and the other one is a DLL. Now, some of the code you would normally have written in your exe, you can now take out of your exe and put in your DLL so that it can be reused again by some other program. So your program itself can use it and another program can use it. So in other words, if there's code that's often reused, then you can take that out and stick it into a DLL. And alright, so if we have a look at some examples of that. So let's say, for instance, you want to build a race car. Well, any car, but let's say we want to build a race car today, for instance. Now, a car consists of multiple parts, all right? A car isn't just a single homogeneous thing, all right? It consists of many other parts, okay? Such as, for instance, the wheels, all right? Now, the wheels don't only have to be used by this one car. They can be used by other cars as well. The same type of car, like what we're looking at here now, the Koenigsegg one. You can say, well, wheels can be used on all cars that use wheels. So that bit of logic, or that piece of knowledge of how to build a wheel, is common to all cars. And the same would apply, for instance, to the body of the car itself. The bodies look different, but some cars, a series of cars from the same manufacturer, all look the exact same. So that's a duplication of that body. So what they do is they build, stamps and punches and so forth that can knock out those panels and so forth, so they all look the same. So in other words, that they figured out a way how to reuse some tooling to create the same door over and over and over, for instance. Another thing is the engine, okay? The engine consists of multiple different parts. Piston, you might have a supercharger or a turbo in there, etc. And that's also common to all cars, okay? There's so many. If you look at an object, if you think about object-oriented programming, as I said before, an object like a car consists of many other objects. Now, a prime candidate for a DLL is these. When I say these other objects, they could be stuck into a DLL, and you can share that code amongst other applications. Let's say you're not the only application, and that you write an application, for instance, that needs to build a car, okay, tell people how to build a car, but then you also want to say, okay, but I don't just want to build a race car, I also want to build a 4x4 for riding in the bush. Okay, a lot of this code is reusable. The idea of how to build a wheel and so forth, that can still be separate. For the race car, the supercar, the hypercar, all cars have the same concepts, and they can be shared. So let's say, for instance, if you had to go a little bit further and start looking at another example of where you would use, for instance, a library or a dynamic linked library, is let's say, for instance, you want to write a program. All right, that's all it really is let's say, for instance, it's a website, okay, where a person can go, they can type in an author name, all right, and you will show them a list of books that the author wrote, and this person can then select one of those books that they're interested in, and start reading it. You display the text to them in the browser, and they can start reading it. Now, this is what I'm showing you here. Now, this is not exactly pseudocode, but okay, it's sort of pseudocode. But so you can see there's multiple steps in here, and in fact, some of those steps, all right, are actually reusable in other programs that require to do similar things to your main program. Okay, so for instance, when you ask for the author name, the second step to open the database, well, that's a little bit of a problem. Like, let's say if it's a website, okay, the website cannot open a database, all right? It has to call something on the server to open the database, all right? So there's already a separation between your code there, all right? So your question can be, well, okay, so you've got the front end that's asking for the author name and so forth, and that can be a website and is written using HTML, JavaScript, and so forth. But the back-end stuff, the stuff lying on the server that's actually communicating with the database, okay, that is not web-related stuff. You can't write that, you know, using colors in HTML and JavaScript and so. Well, with Node.js, I guess you can, but basically you've got a front end and a back end, and there are two separate things. So when you originally planned your program, all right, you had certain steps that you needed to go through, but a lot of those steps can't be stuck into the exact same program, all right, just because your front-end code, all right, the JavaScript, for instance, that's asking the user certain things, it cannot go to the back end and do stuff in the database. It has to ask something else to do that for it, all right. Now, that could, for instance, be a C# program. Now, so in other words, the first part of the program is not C#, that is HTML, CSS, JavaScript, and so forth. So website. And the second side is some backend language, PHP or whatever, and now in our case, C#. So if you look at those steps, all right, you'll notice that you can break it up into a main application and a DLL, all right. Now, the DLL cannot be called directly from the main application. Okay, in other words, from if we consider the main application to be the HTML, CSS, and JavaScript, okay, you can't call that DLL from that code, all right. And the thing is, the DLL contains all the code in it that needs to talk to the database. You've now pulled it out of your main program, out of your design of the main program. Because a website can't talk to a database, you've been forced to pull that piece of logic out. Now, like it says here, that is DLL candidate code. But the thing is, you can't call a DLL directly. So you still need some kind of server or something in between the HTML and the DLL. All right. And now we're not discussing really how to write that today. But the thing is, what I'm getting at is you can basically take your code and start pulling it apart, pulling pieces out, common pieces that can be reused in other pieces of code, in other programs that you are writing. For instance, like in this case now, we're writing a website. What if we later decide to change this to be let's say a WinForms app using .NET, and so that entire front end has changed. Now we can say, well, now we can write all that code into the WinForms app, this DLL candidate code. Yes, that's true, you can do that, but then you lose the reuse of that DLL. So in other words, if you stuck it now the first time when you did the website, you put it into a DLL, okay, the database related stuff, you stick that in your DLL. When you rewrite that website and you make it a WinForms app or a WPF app or a Xamarin app, okay, you don't have to rewrite. You only have to write that code that's specific to this front end that you're working with, the UI you're working with. But the actual communication with the database, that you just stick in a DLL, and these other applications just call this DLL, this library of code that you've written. They don't actually have to do it themselves. So it's actually pulled out that let's say, separation of concerns. It's and made it more modular. Okay, remember, I'll keep harping on about modularity. So we've basically got two, you can think of it almost as applications here, but two sets of code. Okay, we've got the main application, that the one that we actually want to be writing at the end of the day, and then in our design we've realized that some of the code can be reused, and we've taken that and we said, okay, this we're going to put into a different file called the DLL. Alright, so I think let's get into some code, and I'll show you how actually we are going to do that. Alright, so so some of you should remember this code from the previous video I made. For you guys that are new, that I just started watching from this specific episode, all I really did in this application, it's a .NET Core 3.1 application, if I'm not mistaken, on the version. All I really just showed you is how to be able to connect to a SQL Server database from a .NET Core 3 application, and doing basic CRUD method calls, such as, you know, CRUD for create, read, update, and delete. So this is just basic way of talking to the database. Modern way using entity framework and so forth. Okay, so guys, okay, so back to today's video. So what we want to do is, let's say, for instance, let's assume that this program we wrote last time, our first database, was actually just a proof of concept to a client. All right, showing that, hey, yes, we can create the database. Let's say, for instance, on their SQL Server, not ours that we're selling to them, but on their own. It's a big company, it's already got one. So we've proven to them that yes, we can create the database, and yes, from a .NET Core application, we can communicate with the database. They've now given us the project. They're happy. They want to pay. They said, okay, you can go ahead and you can write our program for us. So life is good. So what I really want to do is, because it's a real client, okay, and it's now an actual application I'm going to be writing, there are certain naming conventions that we use. Now, this one, I'm going to keep this one open, all right, or no, all right, that's not the right thing. So I'm going to get rid of this solution. I'm going to create a new solution, all right, that also contains a console app, because that's the program that we're going to be writing. So if I say file and let's say close solution, all right, it'll close it for us. Okay, and then ask us what, let's create a new one. So yes, we want to create one now for our client. So this is our actual live code for a client. All right, it is a console app .NET Core application. So we select that. You can do a normal .NET Framework one, but we are doing .NET Core in this series. Why? I think it's the future of .NET coding in Windows. Not the very near future. You still do okay learning .NET Framework, but I think you should get your fingers wet or your hands wet with .NET Core now. Okay, so all right, so we're going to create a console app. Okay, and it's going to ask us a name. All right, so let's say the client says, okay, we want this application to be called, remember what we're doing here is we're going to be creating a little library application. So this is for a library. So let's say it's for some municipality in a city, their library app. But I don't want to call it library because we might get confused, because the fact that we're going to be using dynamic linked libraries. So you're going to get confused with the names. So let's just call it, for instance, something silly, like Bluetooth. Well, we ever came up with Bluetooth? What does Bluetooth actually have to do with the functionality that it provides? So let's just call our application, for instance, tangent dimension, or let's say let's call it knowledge reader. All right, exciting name. All right, knowledge reader. It will now create for us a folder, all right, in this location here, and it's going to be called knowledge reader, and inside of that is going to create the solution file, and inside of that is going to create a project which is going to actually contain our console application for us. So let's just let that run for a moment. All right, so it's now gone ahead and created our console application. But so far, as you can see, this is our code on the right here. We have none of the code that that does any of the database communication or anything like that. All right, so what I want to do is actually I want to look at that previous code that I wrote. All right. Just to remind myself of a few things. So either I can open a new version of Visual or new instance of Visual Studio and open that project as well, or solution, or I can just look at it using Notepad or something. Alternatively, I can just come here, click on solution and say add, all right, and then I say add an existing project, not a new project, an existing project, all right. And then we just go and we look for that project of ours. I happen to know where it is on the hard drive. All right, so there's our first database. So we go into there and we go and look for the project. Come on, go in there and we get our project file. Double click on that and it'll add it to the list here. So there we have our model like we had and the database stuff related to it. Now, all right. So this is candidate DLL stuff, all right, the talking to the actual database itself, all right. So, but a lot of this code, for instance, all right, if we go and look at our first database program, we look at that code, that's this code here, all right. So we actually want some of that code inside this project of ours. But we can't do it at the moment because we can't get to this database stuff. All right, so now we can create yet another project. All right, and this is going to be a library project, a DLL project. All right, so this is where the trickery comes in. All right, so we go to solution again and we say add new project. All right, and it's not a console app. We want a library. Okay, so we look for library. All right, and here it gives us all our possible libraries that we've got. So we've got .NET Standard, etc., but we don't want that. We want a .NET Core library. Here we go, class library, .NET Core. All right. If you were doing normal .NET Framework development, okay, again I say you would be using this library here, class library .NET Framework. But we are using class library .NET Core because we're doing .NET Core development. All right, and all right. So now we'll give it a name. This new library of ours, and there's various ways, there's many conventions of how you would call these or name your libraries and so forth, but a bit of a standard, okay, is to either start with the client's name, the company name that you're writing this for, and then the program name, in other words, knowledge reader, okay, or the other way around, first knowledge reader and then the company name. All right, now this particular one, I did the actual main application, I did not follow that standard with because I wanted to compile an app just called Knowledge Reader, not the company name .knowledge reader. But for our DLL, we want to do things properly. All right. So depending on which format you choose, but let's say we are going to call it the company name. All right, which is we're writing something amazing here. We're writing it for Microsoft. No, they might get just confused. So I'm writing it for my own company. All right, so it's for dimension 15. Dimension 15. All right. Dot. All right, and we want to call it our database. All right, let's just call it that for now. Dimension 15 and all database related stuff, and it'll put it for us as a new folder under knowledge reader. All right, so we go ahead and we create that DLL. Okay, so it's gone ahead and created it for us, and you see it's created a class for us already. Which, I mean, you don't want to use the name class 1 for anything. This is just a template to get you going. I typically just rename it or delete it. and add a new one. But all right, so that's the beginnings of like our context related stuff, all these things down here. All right, we actually want to pull that out there and stick it inside our library, and then from our library, our DLL, call that from the knowledge reader. All right, so the first thing we need to do is create a link between knowledge reader and the database DLL. All right, because the knowledge reader can't call these classes at the moment inside the DLL. So all you need to do, all right, is on dependencies, we say add a project reference. All right, and that is, so for the knowledge reader, we're adding a project reference, and it'll show us all our possible options within our solution. And so we want to connect to dimension 15 database. All right, so what that means is that once we say okay on that, you'll notice now under dependencies, all right, under projects, it's now created a reference to dimension 15 database in knowledge reader. So this project, okay, is now part of this project. Okay, so because we created that reference, we can now actually start calling these classes and so forth. All right, so as an example, we should be able to get to class 1. Now class 1 is defined as public, so that means outside of the DLL we can call class 1, all right, which is what we want. If it was private, we will not be able to get to it. So let's go to our knowledge reader program. Okay, and let's say, for instance, so we want to create a new instance of class 1. All right, now normally we will not be able to get to it, but because we've done the reference, we can. So what we do is we type in dimension. All right, come on, dimension 15, because that is the reference that we've added, dot, and it should give us database, and dot, and we should have class 1. All right, so we can say class 1 equals new, and we create a new instance of class 1. Okay, and let's say, for instance, class 1 must well, on class 1 there's a function. Let's say, for instance, we'll create a method here. Okay, and it must also be public because we're calling it from outside of the class itself. So this is part of the interface of the class. All right, so we say public do stuff, or let's say do delay. All right, and all this does is just delays for a few seconds. System.threading.thread.sleep. Okay, so let's say this is in microseconds. So let's say we're going to sleep for 5 seconds. All right, that's a bit long, but all right, we're going to sleep for 5 seconds. And sorry, that must be public void. We're not returning anything. We're just going to sleep for 5 seconds. All right, and what's it complaining about here? Oh, I've declared it outside of the class. My mistake. Or not declared, created. So I created it directly in the namespace, not in the class. All right, so now it's part of the class. All right, and it's public, and the class is public. So if we come to our knowledge reader program, all right, so we've created an instance of the class, okay, called class 1. So if we say class 1 dot, okay, and there's do delay. All right, so it's going to delay for 5 seconds. So let's say we want to run our program, but we're first going to say we are delaying. All right, and then after the delay, okay, it's going to write out hello world. So we've basically got 2 different applications here. We've got knowledge reader and the DLL, dimension 15.database. That's just a naming convention. You can call it whatever you want. You can call it knowledge reader database, whatever you want, that's fine. Normally you would say actually dimension 15.knowledge reader.database. But okay, so is this naming conventions here and standards and so forth. So if we have to run this program, knowledge reader, all right, it should call our DLL, all right, class 1, all right, and it should call this do delay, all right, which says just delay for 5 seconds. And then after it's done that, so it creates an instance, it writes out we are delaying, then it does the delay, then after it's done that, it says hello world. All right, short and easy. Now when you're working with multiple projects, okay, in the same solution, one of them is typically the one you always want to start up with. All right, now in this case it's knowledge reader, and it's slightly bolder than the other two projects, so we know that it's already set up correctly. But if it's not, what you can do is right mouse click on it, all right, and you come down to, there should be a set startup project. There it is. Just say set startup project, then that will be the one that if you just click here to run or press F5, it'll run that one. You can run separate ones, okay, like let's say I want to run this one. I don't want to change the startup one, but I do want to run this one as well. Then you can go to say debug and you say start new instance, then it'll run just that one, okay. Or you can run this one, and while that's running, you can also come to this one and just say start new instance, and then you'll have two programs running at the same time. But that's not what we want to do at the moment. So we've got our knowledge reader that's going to start running, and it's going to call this DLL for us. All right, so let's just let's run it. So F5, and let's see what happens. Okay, what I definitely want to do so long actually is just to kill my antivirus for a second. var shields control disable until computer is restarted. All right. Say yes, put the antivirus off for a moment and let this thing run. All right, machine is a bit slow, sorry about that. All right, and there we're running. All right, so it's going to tell us that it's going to wait for 5 seconds or delay. All right, so if you just move it to the side here, it's going to say yeah, we are delaying. Okay, it's still busy building and so forth. It hasn't actually started running yet. Okay, so there we go. I think it's going to start running it now. Alright, so there's running and saying we're delaying, so it's going to wait for 5 seconds. And then it says hello world, and that's the end of the project. Okay, end of the program. Alright, we didn't say it has to do anything else. So so now you can stick anything else, for instance, on class 1 here. Alright. Let's say we do another delay. But a shorter delay, or let's say it must return a value for us, for instance. Okay, so it must be public so that we can access it from outside of the library. Okay, which in other words from knowledge reader, the application. So we want to access it from outside, so it's got to be public. The same as a class must be public. If you make it private, you won't be able to see it. I'll demonstrate that to you just now. So public, let's say we're returning a string, okay, and we'll just call it get string, okay, and we're going to say return and some string. What are we going to say? Return from DLL, boom, and let's make it a hello world from DLL. All right, so we save that, we come back to our main program here, program.cs. So let's get rid of this delay that we called here. All right, but we still created an instance of the class. All right, so class 1. So what we want to do is we want to write line. All right, but what we want to do is write line the results of calling class 1 dot get string. All right, so if we run it now again, all right, and there it is. So said hello world from DLL. So in other words, from our program, knowledge reader, all right, it's moved out of our program into another program, which is the DLL, all right, and it's gone and called the method getString and returned that part of the string. And then if we go back to our original program, it calls that and then writes that to the console. So it writes it out. All right, so that's the basics of a DLL. Now, if I show you, if we take this class 1, all right, and we don't make it public, we make it private, all right, and we save that. Let's see if we go back. Okay, it's telling us it can't compile. It doesn't even know that class 1 exists. Okay, because we've made it private, it's gone. All right, so if we make it public again, okay, public, all right, and we get this string, for instance, we make this private. All right, so what happens now is we've got class 1, which is now public again, all right, but this method is private, so we can't get to it. So because it's a DLL and we do want to get to it, it's got to be public. All right, so let's get rid of this class 1, and okay, so that's gone. Right, and now of course, since that's gone, if we come back to our main program, all right, it's going to give us errors and tell us, you know, this class 1, we deleted this whole thing. All right, this class 1 is gone, doesn't exist. In fact, that namespace in which it was doesn't even exist. So, all right, so what we need to do is, because this is now database related, and we write things in a modular fashion, and you know, remember I said to you about separation of concerns and modularity and so forth. So this is all database related code that's going to exist inside here. All right, so now remember our original project called our first database. We actually want some of this code to be stuck inside of this here. All right, so we could just drag them across, but remember we're going to have a namespace problem, all right, because it's going to have a namespace of our first database. So either we can create it by hand, okay, say add a new class, new folders and stuff, or we can just drag it all across and rename it. All right, the easiest is going to be just to drag it across. That's why I decided to add our first database project to this solution. It's just that I can show you this. So we drag it across to dimension 15 database and we drop it there. Right, it makes a copy for us. All right, so we've now got it at 2 places. All right, so sorry, the only thing that we don't have copied is this stuff in program. So that's this stuff over here. All right, which we can steal some of that as well in a moment. But we'll get to that later. So the first thing we've got to do is, if we go to our DLL, all right, remember our namespaces are all messed up now. All right, so it's showing us our namespace is still first database, but it shouldn't be. It should be dimension 15.database. All right, so let's change that. Okay, dimension. My eyes are a little bit wobbly today still. Not quite over all my dizziness. Not 100% yield, but it's okay. Dimension 15 dot database. All right, and we'll copy that. All right, because we're going to have to redo it constantly many times. All right, and okay, so this DB context doesn't exist. So remember, we have to include some dependencies. All right, so if you look at packages here, these must also be included. All right, into our new DLL. But so that's why we're getting these errors here. So, but let's just continue here. So if we go to clients, for instance, and it's also got the wrong namespace, so we change that to the right namespace. And games has got the wrong namespace, change that to the right namespace. All right, and okay, we can close that down. All right, so this is basically sorted, except for the fact that we need the dependencies. So we need the entity framework core relational and SQL Server. All right, so if we go to dependencies, we say add manage NuGet packages. So this is sort of what we did in our last episode. We're just redoing it again for our new project. All right, so if we go to browse, we search and we say Microsoft dot entity framework. Oh, there it remembers that I've already done these before. So okay, so we'll do a search for that one. All right, that's relational, so we'll install that one. Come install that. Okay, it's got all these dependencies. We just say yes to all of that. That's fine. Accept the agreements. All right, so it's gone and added relational for us. Okay. We also want to do what is the other one called? SQL. Okay, is that on dot? Okay, there's SQL Server. So you want to do this one as well. All right, that's this one. So we want to install that. Okay, it's also got a whole lot of extras that it installs with it. Okay, we say yes to all of that. All right, and so if we come and look at packages here, we've got these two NuGet packages, and in our original, our first database program, we've got the same ones. All right, so that means that dimension 15 database, the DLL, all right, can actually build now and compile, and we can actually start using it to talk to the database. But so let's just go back to model here, and I don't want to call it model, all right, because model is actually referring to a different DLL that we will be using. This is just the database one, so we actually don't want model here, all right. We actually want to stick all of this like context, maybe we can keep. So we just want to get rid of model. So everything inside of model we want to drag out. So take context, drag it out, put it onto the project name. Say yes. Okay, it'll throw that over for us. All right, and then the classes. All right, we want to take that as well. Also put it up onto that level. Say yes. All right, and then model. Okay, we can delete. All right, but now again we look at namespaces. All right, and there's model. Okay, model doesn't exist anymore, so we can get rid of that. Okay, we don't want model anymore. And under games, we don't want model anymore. Okay, and the same would apply to the database controller under context. Model over here no longer exists. Okay, and that means model here must be taken out, and here must be taken out. All right, so that's all fine. Is there any other problems? That should all be good. All right. Okay, so that's that then, and I think let's just close everything, just so close all, close all. Why am I not seeing close all documents? There we go. All right, so we've basically, in our solution, we've got 3 projects. Okay, our first database is the one that we wrote in the previous episode. This we're just keeping because we just wanted to copy some of the code over to our DLL. All right. And but our actual new project is Knowledge Reader. All right, so we must just remember that this code over here, okay, this is what we're interested in using, okay, in our Knowledge Reader as well now. All right, and we can get rid of this project, but once we've done a copy paste maybe, but let's just see. All right, so because we've already created a dependency, okay, if we go to projects, we've created a dependency to dimension 15, okay, like I showed just now. So now we'll be able to start talking to the database. So if we go to program, all right, and so dimension 15.database class 1 no longer exists. We deleted that, all right. So let's just delete all that, and let's say dot, and what does it have available for us? Well, nothing, all right. So that tells us that something is private. All right, and what that probably is our context. All right, so go to context. Yes, if you don't put anything in front of class, it's assumed to be private. So we want that to be public. All right, and all right, so okay, why is this an issue? Inconsistent accessibility. Oh, okay, so that means that these ones as well are also private. So our classes must also be made public. because they are used outside of the DLL. All right, so they must be made public, saying that yes, outside of the DLL, the program that's actually using the DLL must have access to these classes. All right. Okay, so that's it. That looks good. Everything is fine there. All right, so okay, dimension 15 dot. All right, and there it tells us. Okay, so we've got our context. Okay, and we'll just call it context. Sorry, is it context? Do we have a, yeah, the database context class? We'll just call it context. Okay, equals new dimension 15 context. All right, so now we've got the context. Okay, and let's say, for instance, we want to again read from the database. Okay, so let's say int record count, okay, equals context dot what was available to us again in the database here. That was my company, for instance. It's tables. Okay, so we got client games and sales. So let's say we want to see how many what is our total number of games that we have available. All right, so it's context dot games dot count. Okay, can't find count. Why? Okay, sorry. All right, so something else that you have to do is just add up top here using what's it, system dot link. All right, that'll allow us to do a count. All right, so we can say dot count. Count should be there. There's count. All right, we do a count on that. All right, and yeah, we will say games count is record count. All right, so all right, this should call our DLL, talk to the database, and return it to our main application. Let's have a look at that. So we should have some kind of games count value come back. I'm not sure how many there are. We can have we'll obviously verify this in a moment. All right, so there it's come back and it's told that we have got 5 games in the database. Okay, so if we go and verify that, if we come here to games and just say select top 1000, so there should only be 5. Let's just make sure about all of this. All right, there we have it, and we've got 5 games. So so we know the DLL is working. And all right, so if I can just all right, so we no longer need this. If I just collapse everything here, we don't need this, our first database anymore. I just needed to look at some of the code we previously wrote instead of rewriting everything. So I'm just going to remove it. I'm not deleting it off the hard drive. All right, I'm just removing it from our solution. All right, so it's no longer part of the solution. Okay. Okay, so it's gone. So it's still on the hard drive, but it's not part of the solution. We haven't lost anything. It's just not part of this, of our current project that we're working on, our solution we're working on. Okay, so as you can see then, okay, so Knowledge Reader actually has got absolutely no idea about databases. If we go look at dependencies, for instance, if you look at the database dependencies, if you look at packages, we've installed our entity framework stuff. All right, so that we can talk to the database from our DLL. But in our actual application itself, if we go to, well, dependencies, we've got no NuGet dependencies here. We are calling or depending on the DLL, which depends on the entity framework. We don't have anything to do with the database stuff installed in our actual application. However, we can call the DLL and do anything we want to do that the DLL allows us to do. So let's say, for instance, if we go to the context of the DLL, or the context class inside the DLL, like here, for instance, okay, we've got the connection string that is using to connect to the database. In an actual application, you will not put this inside your code like this. You'll probably put it into a config file. But we'll be covering that probably when we actually create a final app, our Blazor application. But alright, so what we're basically telling this DLL is that, okay, it must be aware. We installed the NuGet packages for Entity Framework, so it's aware of Entity Framework, and then we've taken our old classes, copied it over, just changed the namespaces, and it can talk to the database. So, but a DLL within itself, okay, cannot do anything. We can't run it or anything like that. Let's say, for instance, we make the DLL the active project, set the starter project. All right, so you'll notice that it's slightly bold now. All right, so if I F5 or click on the arrow here to try and run it, it's going to give us an error saying a project with an output type of class library cannot be started directly. You cannot run a DLL. All right. But what you can do is you can run a console application. So we set that as the starter project. Now the console application calls the DLL and that starts the DLL up. Now something that's very important to remember about DLLs, okay, is that if a DLL requires any config information, like let's say this application had a config file in it, again, which our Blazor app will have, it can't have its own one. It's going to read the one of the program calling it. Okay, so let's say, for instance, if you had this in the context, this connection string here stuck in a configuration file. Okay, you can't stick in or you shouldn't stick it in a config file which the database itself, the DLL itself tries to access. You just stick it into the program config file that uses the DLL. So the DLL will pull it out of that config file. Just for interest's sake. I'm not showing you how to do it now, I'm just explaining it to you. Alright, but that's basically it. So we have a database file, or a database that's accessible from a dynamic link library to any application that uses the dynamic link library. In this case, it has to be a .NET Core app. Okay, so if we take this a little bit further, and we can, I was going to show you the full making of a library application and so forth, but I actually think this is actually showing enough of what a DLL does. What we can maybe do is just to show you that all this works, is I'm going to create yet another project. Okay, and let's say this is for the same client. Okay, but it's also a console app, but it requires something different than what the main app does. I'll explain to you now what that is. So let's say we don't want library, we want console. All right, so we want a .NET Core console app, and we say next. All right, and we're gonna call this sales counter. It's gonna keep telling us how many sales have taken place. All right, but now that is also an application, so I'm not going to give it the full namespace naming of dimension 15 dot etc. It's just the application name. All right, so it's also a console app, sales counter. It's also going to need to talk to the database. All right, so it needs this dimension 15 database DLL. All right, so what we're going to have to do is we go to dependencies and we add a project reference, and we connect it to the DLL, the dimension 15 database DLL. So boom, immediately sales counter now also has the ability of talking to a database. Why? Because it's using the DLL that we wrote for the database. Same as knowledge reader. But they're going to be using it for different purposes. Knowledge reader can do everything that I showed you in the previous episode. You can add new records, delete records, and do all sorts of stuff. All right. But let's say all we want sales counter to do, all right, is it must just run and every few seconds tell us check to see if a new sale was made. All right, and if there was a new sale made, it must write it to the console and say what the total number of sales at this moment in time is. All right, so it's slightly different logic to knowledge reader. All right, so we're going to write that. So, well, one of the things we can do already is just steal this line. We're going to be using that obviously in this program. All right, we need to create the instance of the database context, okay, of that class of ours, and that will do that for us. So now we've got access to the database, and so what we want to do is we want to check every few seconds, okay, to see if a new sale was done. Let me just check what do we have available in the database here. So yes, we've got sales. So let's just see what it tells us at the moment. What do we have? Select top 1000. All right, so, well, we've got no sales at the moment. Okay, no sales. All right, so we should write all that code. Okay, fine. All right, but so on the sales counter, what it must do, it's a very simple little program, this. So it's going to have a private variable. Let's just say it's an int, all right? It's called, let's say, current sales counter. It starts with a value of 0. Okay, you don't have to specify that, but I like specifying it. You could just say that, and the system knows that, okay, it should start with 0. That's just how the C# language works. But I like forcing it to, telling people I know that it should be 0. I like telling them what my intent is. All right, so what we want to do is, all we really want is a little loop to run, okay, and tell us every couple of seconds to do a check if there's been a sale. If there was a sale, it must update. It must write to the database there was a new sale. Or tell us what the number of sales are that's happened. So there's a couple of ways. You could use a timer for it and all this sort of stuff. But okay, so maybe I should do that. Okay, do it the better way. All right, so it's private timers. Timer underscore timer equals null. All right, and then when we start the system, we also want to start up the timer. Okay, so what we do is we say underscore timer. Now I'm going to say when the timer triggers, what event must be called. This is okay. Here's an example for you how to write your own timer. Okay, this is the pattern that you use. Okay. Plus equals timer dot elapsed plus equals. All right, and it's created this method for us at the bottom called timer elapsed. You can rename it, all right, to just rename both these things in green here. Just rename that to whatever you want it to be, but we're okay with that for now. All right, so timer is not an instance yet. All right, so it's complaining. All right, sorry, non-static. Yeah, so that should be a static because the main is inside a static. So that'll be a static. All right, static. Okay, and okay, so the timer is set up, and what we can do is we can start the timer. Okay, underscore timer. What we've got to do is tell it, yeah, let's just start the timer. Okay, start the timer, but when we create the timer here, underscore timer equals new timer. Okay, and we say every 1 second. Okay, it's a bit often, but okay, every 1 second is going to have to check the database. So we say the timer must elapse every 1 second, and once it's elapsed, Okay, we call with this plus equal, we say that it must call the code that lives inside the method called timer elapsed, which is here, which at the moment is doing nothing. It's just throwing an exception saying that it's not implemented, it's not doing anything yet. We're going to get rid of that. Normally you don't just get rid of that. You normally keep that so that you can see if there's problems in your code. During execution time, it'll tell you that this hasn't been implemented instead of just nothing happening. So you wouldn't know that there's a problem. But all right, so okay, we start it up, and then okay, what we can do is I don't want to keep creating connections to the database. I'm going to do a single connection. So I'm going to create an instance or a field, okay, for the database as well. Okay, so all right, so I'm not going to do this null. We don't have to. All right, then before we start the timer, we first need to connect to the database. So it's context timer equals new, connect to the database, and that should be a static as well. Of course, the method we are in is a static. All right, so now we created the database. Okay, not created a database, but the DLL to be able to communicate with the database. We've set up a timer that's going to go off every second. Okay, maybe just do it a little bit less often, every 2.5 seconds. Okay, and all it must do, it must check the database. All right, so okay, context. All right, context is the one that we're going to use to talk to the database. So context dot what was it, sales, but we don't have a sales where we sell. Yeah, we don't have a sales class here yet. All right, so we can't really do anything with sales. So what we should do is come have a look at sales. All right, so it's a fairly simple one. So it's a client ID, game ID, and date stamp. Let's just sorry, and of course the ID. Let's just copy that over. All right, so we're going to create a entity class for sales. Okay, add new class. So I'm going to call it sale because that's how I normally do things, not sales. Okay, sale. All right. Okay, and it must be public because we are using it in the DLL, and we want users outside of the DLL to have access to that class. Okay, sale, and we paste our fields that we're going to want. All right, and I think I made it along as well here. Let's just check. Yeah, it's also a big int. Okay, should make them ints, but okay. So so it's a long. Oh, sorry, this must all be public as well. Client ID will be a long. Game ID will be a long. And then our current date timestamp. Okay. Public timestamp. All right. Just do all this with them as well. Okay, and just line them up all nicely. All right, so there we have our entity class for sales. All right, this will be able to talk to the database, in other words. All right, but now we need to go to our database context class and tell him that we want to access sales as well. In other words, the class we just created. Okay, db set is sale. All right, and the property though is sales. All right, so we should now already be able to have a look here. So context dot sales dot count. Why is there no count? Do I again not have my forgot to add my using dot link. Sorry, using system. This is just for the count. Okay, using system dot link. So let's say we do a console dot write line okay, oops. Let's call it sales counter. All right, then that must be sales dot count. All right, open close brackets. All right, so every 1.5 seconds, sorry, every 2.5 seconds, okay, this method is going to be called, all right, by the timer, okay, and it's going to write to this the console, all right, the number of sales we have, okay, so not every time a sale occurs, but constantly it's going to say every 2.5 seconds it's going to tell us how many sales there are. All right, so let's just do a Control-Shift-B on that, just build it, make sure everything is okay. That looks fine. It's still building, sorry. All right, so 3 succeeded. So in other words, all our projects built fine. Now remember though that Knowledge Reader is the starter project. Okay, we want to run sales counter though. We want to see how many sales have been done. All right, we don't want, we do want to run both of them at the same time, but for now we just want to run sales counter. But Knowledge Reader is set to be active. So remember I showed you we can either make this the active project, the starter project, or we can say debug and start new instance. All right, so it's going to try and start up and try and talk to the database, and every 2.5 seconds it should tell us something went wrong. Exited with code naught. Oh, sorry, my mistake. Okay, so what's happening is the project that the main is starting, okay, and then it's ending immediately. So before this timer can kick off or anything like that, which is running in the background, that program comes to an end. All right. Now there's many ways of preventing that from happening. Okay. Like a service, for instance, a Windows service, or will take care of stuff like that for you. But you can just do a quick and dirty right here in the main application itself. We're basically going to put a loop at the end here and tell it never to stop. All right, just run forever. Okay, so we'll say do while 1 equals 1. All right, so this will do a loop forever. All right, I do like sticking inside there just a little delay system threading dot. I don't know why. I think this is some habit I developed many years ago. All right, from a different programming language. All right, so it's going to delay for a tenth of a second. Okay, every tenth of a second, it's going to go through this loop. All right, but and nothing beyond this. If there was any code here, it won't run. All right, it's going to be sticking in here all the time. But every now and then, the timer is going to kick off every 2.5 seconds. All right, so if you run it again. Okay, games count is 5. Oh, sorry, I pressed F5. I ran the wrong, I ran Knowledge Reader. So what we want to do is debug, start new instance on the sales counter. some bug it found. What is that about? Second operation. Second operation. Separate thread. I wonder. Let's just try something here. Breakpoint there. Okay, and start that up. Okay, so that's the first time we hit it. Okay, oops, what did I say? Okay, I pressed the wrong shortcut key there, but anyway. Alright, so it should give us a value of 0. Okay, so it's done that, and then it starts the timer again. Okay, there we go, and then it should be 0 again. Okay, so it was just a timer that was kicking off. See, a timer runs on a different thread, and what was happening is, because things were a bit slow on the computer, 2 timers started up within 2.5 seconds of each other, and alright, and they were clashing with each other. So alright, so all we've done now is we said if a timer does kick off, stop the timer, don't let a new one kick off, do what you want to do, and then start the timer up again. Okay, so that we solved our problem there. Alright, so it's just checking if there's any sales, and if there is, it's going to tell us that there's a sale. But let's say, for instance, what's happening now is it's just going to run forever. It's going to keep printing out sales 0, so every 2.5 seconds. And sales 0, sales 0, sales. We only wanted to print it if the sales counter is actually changed. Alright, so what we need to do is, we've got our method here, this current sales counter item. Alright, so what we do is, we say, if, if our current sales counter, in other words, this is the start of the program now, so in other words, it'll be 0 the first time. Alright, if the current sales counter, okay, is not equal to, alright, our context dot sales dot count. Okay, if it's not equal to count, all right, then why is it moaning about that? I suppose it must be a static as well. Yeah, static. These guys, normally we don't use static as much as I am right now, but okay, it's because it's a console app I'm working on. Yeah, all right, so alright, then we do that, and we stick the print into there. So what this logic is telling us is, if the sales our sales counter, this variable, okay, this field variable, if it is not equal to the number of sales actually in the database, then it must print out the number of sales in the database and update itself. Oops. Update itself with that value. In fact, there's a better way of doing this. Okay, let's just do that. All right, and that should be it. Okay, so what's going to happen now is, so the first time it comes around, it's going to come in here and it's going to say, okay, are the number of sales different to our current sales counter? Now remember, this is the first time we get into here, so the value will be 0. So are our current sales counter, which is 0, equal to the number of sales, or not equal to the number of sales in the database? Well, the number of sales in the database at the moment is also 0. So that's not true. So it's not going to print anything out. It's just going to keep going through here and keep checking, keep checking. Was there a change in the sales count? All right. And when there was, it'll go ahead and print this out. So if I just run this now, all right, oh, sorry, I've just run the wrong, let's just kill that. All right, let's again go and say, okay, debug start new instance, and you'll notice that it's just going to sit there and nothing's really going to happen, you know, well, until somebody actually puts a sale in the database. All right, so I mean 2.5 seconds is long past and nothing's happening. All right, well, a lot is happening, the code is running, but we can't actually see anything happening. So let's collapse this for a moment. All right, now let's go to Knowledge Reader again, and in Knowledge Reader what we want to do is we want to add a sale. Okay, but what we want to do is we're gonna ask the user, okay, to press enter. All right, and when he presses enter, we're going to add a new sale to the database. All right, now, typically you would ask the user to add all the sale information or whatever. All right, but let's just do this, you know, let the system do this for us automatically. So what we want to do is we want to say console, oops, console, come on, console.read key, okay, character function press key is plain console. Yeah, that doesn't really matter. Read line, just reads the next character. Well, let's just say read key, that's fine. Okay, so it's going to sit there and do nothing, okay, until you press read key. All right, and then once you press, or sorry, until you press a key. All right, and once you press the key, it must go and it must say, all right, so we don't want to type out this over and over and over. So what I want to do is I want to take this out here. Okay, and I want to put it in using db, sorry, usually you would just say using dimension15.context, okay, but I want to say db, yeah, using db equals, okay. Now that means in front of all my stuff that's inside of that namespace must have db put in front of it. So it's db dot database context. All right, so db dot, okay. Another trick for you to use namespacing there. All right, so what we want to do is we want to say db dot database context dot sorry, sorry, we've already got the context. Okay, so what we want to do is we want to say context dot sales dot add a new sale, okay, and that means we've now got to give him a sale object, all right, inside of the add there. That's what it's complaining about. And then after that, we've obviously got to save it to the database. All right, so then what we do is we say context dot what was it, add or update, or I can't remember, I always forget these things, update, yeah, update. All right, and let's just update everything. All right, update. So update the database. Now what's that complaining about? Nah, man. Oh, save changes. That's what you wanted. Sorry, save changes. Okay. What is that? Except all changes. Yeah. All right. So we do that. All right. Now we have to add the class of the sale. All right. You can do that in one line, like I've shown you before. You can do it on top. But I'm a bit lazy today, so I'm just going to say okay, and let's do it in one line. Yeah. Add a new dimension 15 sale. Open close brackets, and do that as well. Now that's fine, all right, that'll work, but the problem is the properties of sale have no values, all right. So this is the quick and dirty. So you do that behind it, the squigglies behind it, and it'll tell you what all the properties are, all right. Now ID we don't need to set, that gets set for us by the database. All right, so what we want to do is we want to take the client ID equals 1. Okay, let's say for instance, what did I just do? Okay, client ID equals 1, comma, the game ID is, let's say it's 2, okay, comma, and what's the last option we have here? Oh, the timestamp, and that's now, let's say. All right, so that is system, sorry, that must be date stamp equals system dot datetime dot now. All right, and that's that. All right, so what's going to happen is let's speed up this loop here a bit. Sorry, where are we in our sales counter? So let's not do it every 1.5 seconds. Let's do it a bit quicker. Here we go. Let's do it every half a sec. Well, every 1 second. Okay, so don't stress the database too much, and the network and all sorts of stuff in the real world. All right, so what we're going to do is, okay, we're going to, so what's going to happen is this is going to run, all right, it's going to wait for us to press a key. And once we've pressed a key, okay, it's going to create a new sale, it's going to save it to the database and then exit the program. All right, so if we come here, all right, and we execute, we should have nothing in the database. All right, and the other thing is, if we, okay, so our main program is running now, but now we want to start this other one as well. So knowledge reader is currently running, it's waiting for us to press a key, but we want sales counter to run as well. All right, so we say start new instance of that. All right, and that means we're going to have 2 consoles running. All right, so this one, okay, is waiting for us to press a key. Once we do that, it's going to write a sales to the database, and this one is going to tell us that we just made a sale. All right, so it's 2 different applications using the same DLL to do all that functionality. Okay, so if we are here, click enter. Okay, did that not work? No. Okay, there we go. Something happened. Foreign key. Okay, so one of the keys that I added, the clients column ID, yeah, clients doesn't exist, so there is no client that I've just given it. Client ID 1. Okay, so what clients are they? Let's see, where do we have? Here's our clients. Let's just do a top 1000 on that as well. Yeah, there's no 1. All right, what's the chances? Okay, so we want to make a sale for Stephen Smith. Okay, so it's 3. All right, so let's go back here. We can look, there's still, if we execute, there's nothing here. All right, so if we go to, yeah, the client ID is 3 for Stephen Smith. Stephen Smith just is going to buy a game from us. All right, so let's start that up again. Okay, so knowledge reader is starting up, and then we're also going to start up sales counter. It's got to just start up, hang on. All right, so it's started up. Okay, now we can come and start up sales counter. All right, and like I said, so we should have 2. Okay, there's our 2 console apps running. All right, so we press a key on the first one. All right, and it's going to try and write to us. All right, it wrote to the database, and sales counter automatically updated itself. All right, and but only once. All right, so if I close this window, all right, and then start it up again, So now we're going to add another cell. So remember, this one is still running. So this one now must be started by saying debug start new. Oops. I don't know what I just pressed there, but I pressed something. I think I said with debug. But let's forget that. So if I say continue, all right, so it's waiting for me to again press a key. Now look at this one over here, all right. So if I press a key, boom, and we now have 2. All right, so what I've shown you now is the use of a DLL, all right. So we've got 2 different applications, okay. Neither of them know how to deal with the database, okay. Knowledge reader and sales counter, they don't know how to deal with the database whatsoever. However, this DLL that we created does, all right. So we put in all our code into here, okay, into this database DLL, all right. And all that happens is these other applications, the 2 console apps, just call the DLL. They just do calls to the DLL and ask it to do stuff for them. All right, so that means that they are no longer also bound to a specific database backend. All right, at the moment, all right, they are calling dimension 15 database DLL, all right, because that's the reference we created. But really, all that really matters is that the interface stays the same, and then for that DLL, and we can switch it out with a different DLL that, for instance, instead of writes to SQL, writes to XML or to a text file or to a DB2 database or to MariaDB, MySQL, whatever the case may be. So you can switch it out and do things with it now. So in other words, your code, and that's without changing your console, your actual applications. You just change the DLL and your applications will just suddenly work the way the new DLL requires them to work. Of course, once you give them the new DLL and you copy it over onto the machine and whatever. But that's really what a DLL does. It's used constantly. You know, if you're writing a large program and you're not using DLLs, then you should start asking yourself, well, why? Okay. What has happened lately, though, is back in the past, you still have what you call tiered architectures, okay? And typically back in the day we just used what was called the 3-tier architecture, which means that you've got a front end, a middle, and a back end, okay? The middle being normally your business layer, okay? Today it's typically referred to as a model, all right? But it comes down to the same thing, all right? So back in the day, you had your front end, which was all your HTML stuff, for instance, or your WinForm stuff and so forth. And then it would then call a DLL, all right, that contains your business logic, in other words, your model or your business layer. And then it, when it needs to talk to the database, it would have a reference again. So that's a DLL on its own, all right? And then it would reference the DLL to write to the database. You can have multiple DLLs being referenced by your application, and DLLs can reference other DLLs as well. All right, so it's not just there, so you're not limited. Okay, but so like I say in the way back, so we would typically have your front end stuff, and then you'd have a server. The server would start up some application which will call a DLL, which is your business logic, and that will call another a DLL, typically called your data access layer, and that will talk to your database. All right, so you've got, you know, these multiple applications and DLLs and databases involved, all creating one cohesive application. Nowadays with ASP.NET MVC, for instance, and .NET Core itself is ASP.NET Core or something, I can't remember, but Blazor, in other words, is MVC based, and that is a form of 3-tier architecture. But typically with them, you normally leave your model, okay, not in a different library, but as part of your main application, being your website, your web application, your Blazor application, your ASP.NET MVC application. But that's not really the right way of doing it. These things should be living in DLLs on their own, so that other applications can use them as well if needed. But we're going to be looking at that as well. But that's the basics of DLLs. So, now I'm not sure if I mentioned it earlier, but the static library versus the dynamic library. All right. Now, what a dynamic library does, a DLL does, is you actually need the DLL, all right, as an existing file. Okay, so like I've created this project now, like Knowledge Reader. Let's go and look at its output directory. Open folder in File Explorer. So if we go to where it actually built the exe file, you'll notice that it's also, so that's in the bin folder and then in debug. Now you'll notice that it's also added the DLL. There we go, dimension 15 database.dll. All right. So our exe directly accesses or references that DLL, and the entire DLL gets put into a folder where it can access it. All right. There's many places where the DLL can be put. Typically, it's in the same folder, but not necessarily. But that entire DLL might be massive. All right, it might be 100 gigs in size, and you actually only want one little function inside there. Now that's where static linked libraries come in, statically linked libraries, and in one sense they are better, and in another sense they are not better. So it depends what you really want to do. Now, C# cannot create static linked libraries, only dynamic linked libraries. Now with the static linked library is when you compile your program, the exe, for instance, that requires one function out of your 100 gigabyte size DLL. It'll take that one function, it'll take the code of that one function, okay, and put it inside your exe, and that's it. So your exe will grow by a couple of bytes, all right, because it's taken that little bit of code. But if you didn't do it, and that's it, you don't have to, when you send people your executable, you don't have to send them any DLLs or anything. Okay, all the code is in your exe already. Okay, it's been statically linked. Now, dynamic libraries, that whole library would have to be transported with your application. So if it's 100 gig in size, it's a 100 gig library that has to be passed around. All right, and even though you're only using one minute little function in there. But that's the downside of DLLs versus static linked libraries versus dynamic linked libraries. I mean, I take like the .NET framework consists of lots of DLLs and so forth, and it's massive. So if you want a .NET framework application to run on someone's computer, you've got to make sure that they've got this framework installed on their computer, or you've got to add, like in this case, all these DLLs, okay, are added with your application because it uses them, even though you're not aware of it. You know, I didn't specifically say I want to use Microsoft extension options, for instance, but due to some of the NuGet packages I installed, those things were added. So it's actually just for a quick, small little app. There's a whole lot of DLLs that gets added as well. But it does make things very powerful, code reuse and so forth, separation of concerns. I mean, you can write, for instance, an entire FTP server in a DLL and just call that FTP server from your applications that require FTP services. It's as an example. So yes, if you, for instance, using something like C++ or Rust, you've got the option of using statically linked libraries. And in some cases they are the better choice, but in some cases they are not. It really depends, but with C#, you're stuck with, you can call statically linked libraries. You can call other libraries that are not written in C#. I can call the Windows API itself. All right, you often do that for extended functionality that, you know, the .NET Framework can't do. And yeah, so, but that's really it, guys. I think I'm not sure I did this video justice. I'm getting a bit sore again. I think I want to call this end. And so that's basically it. And so you know the basics of writing a DLL. Now, the next step was that I was going to show you guys now how to write a Blazor application, but I think I want to do one more just before we get to that, and that is multi-threading. All right, we're going to be looking at the new way of multi-threading using tasks versus how we used to do it a few years ago by calling threads directly and creating threads ourselves and so forth. Tasks is basically just a wrapper for threads, but I don't want to get into those details now. But that's our next thing. We're going to be doing multi-threaded development in our next video coming up in the next episode. Well, guys, thanks a lot. Thanks for listening. Hope I helped you again. And yeah, please let me know. It'll be great to know I've helped someone. Thanks a lot, and I'll get you next time. See you, man. Goodbye.